All right, here we go. Let's go through the sky this month. I'm covering the period from tonight until the next meeting, which is October 10th. So we're spanning the next 4 weeks. As usual, I'm going to talk a little bit about some space exploration news and updates, and then review some this month in history information. Then we'll get into observing and cover sun and moon, planets and dwarf planets, what they're up to, talk about a comet that's obviously available right now, asteroids, satellite passes, occultations, and early fall targets to look at. And all of this will be uploaded to a document that I'm preparing and putting on the website at RASC-TC. So I'd like to acknowledge some of the pictures by members that I'll be using in this presentation, including Steve McKinney and Michael Watson and Lynn Hilborn. And this is one of Michael's Milky Way shots right here. So in case you're feeling drowsy and you want to fall asleep, here are some headlines just to sort of preview what I'm going to talk about. We have longer nights, obviously, at hand now. We're into aurora season, and I'll cover a bit more about that. We have Comet 21P Giacobini-Zinner doing a number of encounters because it's going to be actually flying down the Milky Way over the next month. Look out for zodiacal light over the next 2 weeks in the mornings. We have an asteroidal occultation on the 16th. We have the moon occulting a fairly bright star on the 21st. We have the equinox on the 22nd. We have an opportunity at a convenient time to watch Algol brighten from its minimum on the 30th. And then we have a number of ISS evening passes starting up in the next week or so. So in terms of space exploration, there's nothing too high profile or exciting in the next next month of launches, although I will mention that a couple of these launches are being done by India, which is great to see. They're coming along. We've also got supplies heading up to the ISS from Japan, and this is an interesting one. It's an air launch rocket where they drop the rocket out of an airplane and then it fires its engine and takes off. And a lot of these are actually Earth observation programs, ISAT-2, the ICON satellite, and Novosars, radar imaging and Earth observations. So good to know the other countries are doing their part. So here's an update on the Dawn space mission. So Dawn has sort of dropped out of the headlines, but it's nearing the end of its mission, and it's now because they've done all the science that they had planned to do. They're now able to take more risks with the spacecraft, and so they've been dropping the orbit down closer and closer and closer to the asteroid Ceres. And this is a high-res, close-up picture of a place called Cerealia Facula, and all those white spots that we saw on Ceres earlier on as it was approaching the asteroid are sodium carbonate deposits that have been brought up in brine. They think there's internal heating inside Ceres, and there's some means for liquids to sort of come to the surface and bring up these deposits from below. So the imagery in this picture has been taken from as low as 35 kilometers above the surface. And it's draped on a topographic model. So there's no vertical exaggeration on this picture. It's the actual how it would look. The spacecraft's about to exhaust its hydrazine attitude control supply. And once that happens, the mission will go dormant, and they'll just let the spacecraft orbit Ceres for decades. They don't want to risk contaminating the asteroid by crashing the spacecraft onto Ceres, so they put it into a protective orbit that they expect will last for at least a few decades. Maybe somebody, Elon Musk III, might go out and collect it at some point in the future. Who knows? The Hayabusa 2 spacecraft is now arrived at the asteroid Ryugu, and it's getting ready to do a sample return and bring that back to Earth. And this is a little diagram that shows shows that it's going to come in and touch down, grab a sample with its arm, and it's also going to deploy some little hopper probes. And they just have a mass inside them and an actuator that makes the mass flip up into the top of the satellite so that in the low gravity of the asteroid, it'll just drift up and then land somewhere else on the asteroid, and it can hop around using this little mass tossing technique. So this week, it's going to do a rehearsal for the actual sample grab, and I'm hoping I get these videos to play. No, I've had some videos that were in here that are not playing, but it's the touchdown. The sample return is due to happen in late October, and this week they're going to approach within 40 meters of the asteroid and just sort of practice, bring it up. And if you want to see some really wonderful 3D animations of the asteroid, you can go look up Roman Tkachenko, either on Twitter or on his Instagram page, and he's got some amazing 3D models that he's animated. The Juno spacecraft still doing its thing around Jupiter. It just did its Perijove pass number 15 a couple of days ago, and these are close-up images that have been prepared by Sean Doran, and he's got a website and a Flickr account that has loads and loads of these fantastic processed images that you can actually access and download yourself and play with if you like to. And a couple more things that we're just keeping an eye on. Of course, we've got the New Horizons spacecraft is less than 1 astronomical unit now away from its next target, which is the 2014 MU-69 Kuiper Belt object nicknamed Ultima Thule, and that's going to happen on New Year's Day of 2019, so it's just a few months away. And then we've got OSIRIS-REx, which is another asteroid touch and return sample mission, and that's due to rendezvous with asteroid Bennu at the end of the year in December. So in terms of this month in history, we've got some astro birthdays. In 1764, we had John Goodricke. He was an English astronomer, and he researched periodic variable stars, including Algol, the eclipsing binary. I'll talk a little bit more about Algol a little bit later in the talk. In 1874, we have Gustav Holst, who composed the Planets suite. And of course, Pluto hadn't been discovered at that point, so Pluto was not part of the Planets suite. And then in 1918, we have the birthday of Sir Martin Ryle, who's a pioneer of radio interferometry. We're marking the passing of Edwin Hubble at the age of 63 in September 28th of 1953. And he of course, used the 100-inch Hooker telescope at Mount Wilson. That was the only telescope larger than the David Dunlap Observatory telescope when that telescope opened in 1935. The 100-inch was the only one bigger on the planet. 1958, we have the birthday of Neil deGrasse Tyson, American astrophysicist and science popularizer. 1873, we have Hertzsprung, Einar Hertzsprung, the astronomer that worked with stellar classification and co-developed the famous Hertzsprung-Russell diagram of stellar evolution. And finally, in 1958, we have the birthday of John Grunsfeld, American physicist and astronaut. There you can see his day at the office. In 1965, Lost in Space premiered only weeks after Star Trek, but not everybody was happy about that. But the Lost in Space people, they didn't care. In 1959, we had Russia's Luna 3 take the first photographs of the moon's far side. And then in 1977, Voyager 1 imaged the Earth and Moon together for the first time. So there we have the Moon and Earth back in 1977. In 2003, the Galileo spacecraft was impacted into Jupiter to end its mission. There's a little cartoon showing some of the orbits that spacecraft did. And in 1846, we have Johann Galle discovering Neptune within 1 degree of the predicted position, and he confirmed it over the next couple of nights. He never took credit for that discovery, although he's the one that did. 1905, we have Einstein's E = mc² paper was published. All those soldiers paying tribute on the aircraft carrier there. And this is cool. In 1858, William Usherwood took the first ever photograph of a comet, Comet Donati. It was a 7-second exposure with a f2.4 portrait lens, but that photo has since been lost, unfortunately. So we have this artist's rendition instead. And the following night, G.B. Bond at Harvard took the first comet images through a telescope. He took a number of exposures, actually took through a telescope. In 1923, Edwin Hubble identified the first ever extragalactic Cepheid variable star, designated V1, in Messier 31. There it is there, right, that little spot, and here are a series of frames showing its variability over time. 1957, the Soviets put up Sputnik 1, first man-made object to orbit the Earth, and of course, in response, NASA was created a year later, and we're just celebrating NASA's 60th anniversary on October 1st. Also in 1995, the first exoplanet was discovered on October 6th, and it was in orbit around the naked eye star 51 Peg, which you can see on a dark night, sort of sitting here off the western side of the western edge of the Great Square of Pegasus. And they used the radial velocity method, where the planet was tugging on the star, and the radial velocity measurement could be graphed up, and you could see how the star was being yanked back and forth by the large planet. It's a hot Jupiter planet orbiting around that star. So in terms of star parties and opportunities to come for everyone to use their new smartphone holders, we've got a number of our RASC events over the next little while: Dark Skies, Millennium Square, City, and the Solar Observing. And I'm sure Ralph will recap those later. Also wanted to mention the Lennox and Addington stargazing events that happen on September 14th and 15th, and the Northern Lights Festival in Kluane on the 21st and 22nd. And there's also Frontenac stargazing in Ontario on October 6th. And I thought this was fun. I grabbed this map of the light pollution map for Southern Ontario and plotted stars on it where RASC members typically go observing. And so you can see, of course, we've got the Science Center and Bayview Village and the DDO embedded in the bright city lights. And then we've got Forks of the Credit to the northwest and York Soaring, which is in a bit of a better zone. And of course, the darker, or so the whiter the color, the bluer the color, the less light pollution there is in this map. In the northeast, we've got Glen Major Forest, and then about twice as far away is Long Sault. And you've got our CAO up here. It's just too bad the CAO wasn't maybe a little bit over here. It's a little bit better. Of course, Collingwood is starting to really bother the skies at CAO. And then here's where the North Frontenac and Lennox and Addington sites are, off to the east, Peterborough area, where the skies are darker. So observing, keep your eyes out for the zodiacal light. The zodiacal light is interplanetary dust particles in the plane of the solar system that are illuminated by reflected sunlight, and they sort of form a wedge parallel to the ecliptic, visible for the next couple of weeks in the morning sky. So rascals are invited to participate in mapping light pollution through the Globe at Night program. This month's focus is on Cygnus, and if you go to the globeatnight.org website, you can download sky charts, which you then take outside and try to determine which of these magnitude limits you can view from your observing location, and then report your findings. So here you've got the summer triangle stars around 2.5 mags, but then we get down to 4.5 mags. You can start picking up Deneb and the rest of Cygnus sort of running the wings this way, and Albireo sitting in the middle. So here's the website you can go to, globeatnight.org, and the observing period runs from the 1st to the 10th of October. So sunrise and sunset over the next period of a few weeks, we shorten the number of the hours in the day from 12 hours and 40 minutes down to 11 hours and 17 minutes of daylight. We have the autumnal equinox for the northern hemisphere on the 22nd, and we can expect enhanced aurora during this time because when the Earth is tilted when the Earth's axis is tilted sideways with respect to the sun, the Earth's north polar magnetic field vector is diminished, and that allows more solar magnetism to invade our magnetic field. So that's why you get enhanced aurora near the two equinoxes. Astronomical twilight, the astro imager's friend. So the sky is not truly dark until the sun is 18 degrees below the horizon. You can see first we have civil twilight, then nautical, and astronomical twilight is the period between 12 and 18 degrees. As soon as the sun gets lower than 18 degrees and its sunlight is no longer able to scatter off the atmosphere or refract over the horizon, the sky becomes truly dark, and that's when you want to start taking your astro images. And so tonight, astronomical twilight ends around 9:11 p.m. We'll start at 5:14 tomorrow morning, and we're actually gaining about 3 minutes per day of night observing time. So we have about 8 hours of imaging time right now, and then a month from now, that increases to 9.5 hours of imaging time, if you don't mind the cold. It's going to get colder, but it's also going to get darker longer. And there's just a graph of the balance between the daytime and the nighttime through the course of the year, and here's the period of the next, from tonight's meeting to the next meeting. You can see that the nights are getting longer. In terms of moon phenomenon, we've got the first quarter moon on the 16th. We've got the full harvest moon happening on the 24th. it's the harvest moon this time because it's the full moon that occurs closest to the equinox, the fall equinox. Last quarter on the 2nd of October, and the new moon happens on October the 8th. And International Observe the Moon Night is on October 20th. Now, just to explain what's happening with the harvest moon and why it's so interesting and important, is that around the time of the autumn equinox, the ecliptic is highly tilted, is very shallow with respect to the horizon. You can see here's the moon's orbit, roughly parallel to the ecliptic. And so what that means is that the moon rises at almost the same time for a series of nights around the full moon. It's only about 27 minutes difference on the nights on either side of the full moon. Whereas near the winter solstice, the moon is rising more than an hour later every night. So what this means is that around the harvest moon time, you can sort of go do your evening walk with the dog, and you can say, oh, there's the moon. And then the next night, almost around the same time, the moon's there again, and you sort of keep noticing it night after night because it's not changing very much. All right, so where are the planets up to these days? So right now, in the early evening, we've got, this is the sky for September 26th. We're going to have Mercury sort of hanging out near the sun and not visible. And we've got Venus setting in the early evening, followed not too long after by Jupiter. And then, of course, towards the time the sky gets nice and dark, we've got Saturn and Mars in the southern sky. And then we can start picking up Neptune. And if we wait till midnight, we've got Mars, we can pick up Neptune and Uranus nice and high over the southern horizon, sort of their optimal times when they're highest above the horizon. And you've got the asteroid Juno is available as well. So what's going on one by one? So Mercury is still observable with difficulty for the next few days. It's going to show a nearly full phase in your telescope. It will reach superior conjunction with the sun on the 21st. And after that, it's going to join the morning sky for a poor apparition for the northern hemisphere. The ecliptic is too shallow, and Mercury will be sitting below that ecliptic, so it's not going to get very high above the horizon before the sun rises. Venus's long apparition is coming to an end. We've been happy to have it in our skies for months and months and months, but now it's rapidly dropping towards the sun, and by the end of September, we'll be pretty much done with Venus for this year. It's going to reach, though, its maximum brightness on the 21st of magnitude minus 4.78, so it's still not finished getting bright. Right now, it's waning in phase and growing in size because it's actually approaching the Earth and starting to move in between the Earth and the sun. And right now, it's setting about 8:30 p.m., and as I said, it has about magnitude 4.7 in it. It's showing about a 32% full illuminated phase in a telescope. Mars is going to remain visible in the southern and western sky after dusk for the next little while. It's in western Capricorn. It sets around 2 a.m. now, and it'll set by about 1:30 a.m. at our next meeting. You can look for the moon sitting about 4.5 degrees to the north of Mars on the 19th of September. And just for those sort of interested in what Mars is going to look like in your telescope over the next little while, so here's the graph. The yellow line is Mars's magnitude or its brightness, and the red line is the size of Mars's disk in your telescope, and the green bar here is where we are now. So you can see that both Mars's magnitude is decreasing, and so is its disk size, although it's shrinking in size faster than it's dimming. The slope of the disk size graph is steeper than the magnitude graph at this point. So we've really gone past the peak, the really good time now, but it's worth tracking down still for the next while as it slowly leave it in our dust. Jupiter, we're entering the closing days of our Jupiter observing for this year. It won't be back in the evening sky till about next May. Right now it's setting about 10 p.m., and by the time of our next meeting, it'll be setting around dusk, around 8:17 p.m. And you can look for the moon, the young crescent moon, sitting about 4 degrees to the northwest of Jupiter on the 13th. That's tomorrow night. Saturn, if you haven't noticed, Saturn has been hanging around near some really cool deep sky objects for the last while. It's sitting above Sagittarius, above the teapot of Sagittarius, right next to the Milky Way. And right about now, it's only a couple of degrees, or half a degree, near the Trifid Nebula and the Lagoon Nebula. So wait for the moon to disappear and then have a look and see if you can see it there. Sets around 12:30 now and about 10:42 by the time of our next meeting. So the ice giant Uranus is an all-night target, rises after 9 p.m. It's moving retrograde in Aries. It's actually moving more or less directly towards the star Torcular or Omicron Piscium. So you can use that. That's a naked eye star. You can use that to sort of find it. And this is the track over the next month of what it will do. Likewise, here's the track of Neptune over the next month. Opposition was just last week, so it's an all-night target now. It's in eastern Aquarius. It has a magnitude minus 7.8. And it's actually sitting midway between Phi Aquarii and this star Hydor. And you can sort of split the difference and find Neptune using those with binoculars or telescope as your guideposts. Now, in terms of looking at Algol is sort of a great beginner variable star observing technique for beginners. So Algol, of course, is sitting here in Perseus. It's in the northeastern sky, and it's an eclipsing binary system, which means it's got a main star, and then it's got a smaller star in orbit around it, and the orbit of the smaller star is essentially in the line of sight between us and the main star, so that every 2 days, 20 hours, and 49 minutes, the minor star passes in front of Algol, and it diminishes the brightness. So here's the observational light curve. So it basically maintains a magnitude of about 2.2 most of the time. And then for about 10 hours, every 2 days and 20 hours, it drops to magnitude 3.4. So if you want to, if you find the minimum of Algol, then all you need is 5 hours to watch it to return back to its full brightness. And it's a noticeable amount, a noticeable difference. So the Observer's Handbook lists these minima of Algol for you to notice. And I've just mentioned that on the 30th of September, there's one that starts at a relatively convenient time of 9:45. So if you wanted to start around then and look at Algol again after midnight, you should be able to notice that it's brightened considerably. So that's a way to get started on variable stars. In terms of what's happening in minor planets, another 1,170 minor planets, near-Earth objects, those are the red dots, have been discovered since January 1st of this year. Another 5,000 minor planets. We're finding more and more of them all the time. And of course, we're interested in inventorying these objects in case we find any that might threaten the Earth in the future. And we've already found another 33 comets this year. So a rate of about 4 a month. Speaking of comets, so here's a great picture of comet 21P, Giacobini-Zinner. So 21P refers to the fact that it's the 21st periodically returning comet. It has a period, I think, of about 6.5 years. I can't remember the exact number right now. But it just reached perihelion and perigee, which is roughly happened around the same day on the September 10th, because its perihelion occurs at about the distance of Earth. So it was near Earth and nearest to the Sun around the same time. And here's a picture that was taken on September 9th showing Messier 38 and 36 and the Spider Nebula in Auriga as it passed through that constellation. And here's the light curve. So this is a little out of date, but we're sitting here in just past September 10th or so, and so we've reached a peak magnitude of about 7, and now it's going to slowly start declining again. But while it does that, it's going to do some cool things. So its orbit, this is the orbit over the next 4 weeks, from the top of the arrow to the bottom of the arrow. And it's going to basically fly right down the Milky Way, the winter Milky Way. So right now, it's in the northeastern sky. It doesn't rise till about 11:30 p.m., so you want to sort of stay up late. And it culminates after sunrise. So it just gets higher and higher and higher, and then the sun comes up and spoils the party. But here are some of the encounters that we're going to do over the next few months. So it's going to pass right through Messier 35 on the 15th. It's going to fly past the bright star Propus and the Jellyfish Nebula on 16th and 17th. It's going to pass near the Christmas tree / Cone Nebula on the 24th. And then it's going to sit really close to the Rosette Nebula on the 26th. That'll make a fantastic picture. And then if the brightness holds up for us, it's going to pass near Messier 50 on the 8th and right through the Seagull Nebula on October 10th. So there's some opportunities to try to look at the comet through the telescope or take some long exposure photographs to see if you can catch it with some of these deep sky objects in the Milky Way. Meteor showers, we just have one meteor shower starting up. That's the Orionids. Will start before the time of our next meeting, but it doesn't actually peak until about a month from now, and that's about a rate of about 10 or 20 meters per hour. Unfortunately, there'll be a nearly full moon for this year's Orionid, so it's not really something to worry about. And the radiance up between Gemini and Orion's cloud. In terms of satellite passes, right now we've got morning passes that are going to persist until about the 18th of September, and then we'll transition to evening passes on the 20th, and most of those will happen between 7:30 and 9:30 p.m. And here are some brighter ones. I've listed them in the handout that I've posted on the website. See, there's a really nice bright high one on the 10th of October. In terms of iridium flares, those are the glints of sunlight off the high passing iridium satellites. And these iridium flares are becoming on the verge of becoming extinct because these iridium satellites are being deorbited and taken off the system and replaced by ones that don't flare. Most of the current iridium flares are occurring now between 7:30 and 9 in the evening and 5:45 to 6:30 in the morning. And you can find out when they happen by going to heavensabove.com and entering your location. There are also smartphone apps that list them, and I do tabulate them in my weekly Skylights blog, that you can also refer to that as well. Occultations. So I picked out one good occultation that I noted for the month. On September 16th at about 5 in the morning, this fairly bright asteroid, 11.8, magnitude 11.8, called Sappho, which is in Taurus, is going to occult this star, magnitude 7.2 star. So that's pretty doable. Dipping 4.61 magnitudes for 5 seconds at an altitude of 69 degrees above the horizon. And you can see that the standard deviation for the predicted track, which is down the center here through Aurelia, anywhere between the blue lines, you're within 1 standard deviation of that. And of course, there's the CAO sitting right on that track. So if you want to head on up to Lake Simcoe or head over to the CAO to try to catch that, that would be a good one to try for. And then lunar occultations. So the moon on the 21st is going to start in daylight. So it'll cover the star Delta Capricornus in daylight. The star will disappear behind the dark limb of the moon. And then by 8:10 p.m., it'll be in a darkened sky. The star will reemerge from the bright western, eastern limb of the moon. And this is the sky shown at 8:10 p.m. I'm going to list some other multiple star occultations this month. So Mu Ceti, 16 Gem, New Gem, and Delta Cancri, those are all multiple, double, or triple stars. So it's really interesting to record the behavior of those as they get occulted by the moon. The AAVSO asked for data on those objects. So what do you want to look at for the next month? Well, you want to look at objects when they're highest in the sky, when they're crossing the meridian, and when they're through the minimum amount of atmosphere. So this big blue circle here is the boundary between lots of atmosphere when things are low and the minimum amount of atmosphere when things are high in the sky. It's called the amount of air masses. And so the constellations that are going to be on the meridian, some of them we have no choice about. They will never get this high, but we've got Corona Australis, Sagittarius, Scutum, and Serpens Cauda. And then constellations that get into the thinner atmosphere up above would be Aquila, Sagitta, Vulpecula, Cygnus, Lyra, Eastern Draco, and Cepheus. That would be at 9 p.m. Then by 11 p.m., we pick up Microscopium, Capricorn, Western Aquarius, Equuleus and Delphinus, and the western part of Pegasus. And we got Cygnus, Lacerta, and Cepheus, and part of Draco again. And then at 1 a.m., stay up late, you've got Sculptor, Pisces Austrinus, Aquarius, the western part of Pisces. You've got Pegasus and the Andromeda, and Lacerta, Cassiopeia, and Cepheus. In terms of what you might want to look at, some of the all-stars, things you can just show people with their naked eyes, would include the teapot asterism and the summer triangle. If you've got binoculars, you can point out the coat hanger up inside the summer triangle and the square of Pegasus. Globular clusters to look at would include M13 and M92 in Hercules. We've got M22 in Sagittarius, and M2 in Aquarius, and M15 in Pegasus. Early fall blobs in the sky, double cluster in Perseus, Andromeda Galaxy in Andromeda, the wild duck cluster M11 in Scutum, M33, which is dim, but you could try for it. And you've got the Heart and Soul nebulas in Cassiopeia, and the Veil in North American and Crescent nebulas in Cygnus. And in terms of sort of planetary nebulas, you've got the Ring, the Dumbbell, the Blinking Planetary, the Blue Snowball, and the Cat's Eye. And don't forget the Owl in Ursa Major. And double stars include Albireo, the double-double, Marfic in Hercules, and Almach. And it's fun to teach people the bright stars. So why not point out Antares, Vega, Altair, Deneb, Arcturus, and Capella. So hope to see everybody out at some of the observing sites at Long Sault and Bayview and the CAO and even DDO. And that's it for me. Thanks.
Hey, Chris, talking about Mercury, it's just finished morning apparition now, so it's going to be an evening apparition. I think you might have said morning apparition.
I may have had it backwards, sorry. Yeah.
Yeah, it's going to be
You're
in the
the
evening
expert,
somewhere.
Ed.
Thank you.
Chris, I have a question myself. What is the source of that light pollution map that you showed?
Oh, if you Google light pollution maps, there's someone has created this map. It's a Google map that you can zoom in and out of, and then it's got about 8 layers on it. So you can actually look at historical evolution of light pollution over time. I'll include the link in the notes. But yeah.
Any
Great.
more questions for Chris? No? Very good. Okay, thank you,
Thanks.
Chris.